Good afternoon, class. In today's video, what I wanted to do was to go over an example from circuits. So this will be from circuits part 1, circuit problems part 1. This will be number 2 and number 6. So the reason I did that was because there was, of course, one of them is in series, the other one is in parallel. So I thought, well, might as well hit both of them in the same video. So here we go. R1 is going to be 64 ohms, and R2 is going to be 34 ohms. And so the question is, how much is the total resistance? Good question, you may ask. But of course, what equation do we use? Well, as we've seen from the notes from quarter 4, in series, the total resistance is going to be R1 plus R2. Very simple. So in this case, it's pretty much a no-brainer in terms of how to mathematically handle this problem, because it's just going to be 64 plus 34, which is 98 ohms. So that's it for number 2. Fairly simple. But number 6, this is where it gets a little bit more extreme. So what I thought I'd do was I take some more time, and I hope you notice that. That's why I did this in different colors, so that you can kind of see how much effort goes into each of the problems, just so you can get an idea that with parallel circuits, you've got a lot of work. It takes a lot of work to set it up, but it still mathematically will be about as straightforward as series circuits. It's just that the setup takes a lot longer because there's a few more, the physics is a lot more complex when it comes to parallel circuits. So in number 6, we've got R1 being 76 ohms, R2 being 45 ohms, which means, of course, when the question is raised of what is the total resistance, well, they're in parallel. So we have to use the equation for that, which is 1 over R total is equal to 1 over R1 plus 1 over R2 plus whatever. And of course the same thing in series, right? It's R total is R1 plus R2 plus, and you just keep going. However many elements there are to that circuit, that's how many elements you would add. So in this example, I only have 2 elements, so I only have to worry about those 2. So what I'm going to do, I need to find R total. I don't want 1 over R total, I want just R total. I could just invert the whole thing as well. I could just say, oh, I'm just gonna invert both of the fractions. Oh, but there's that nasty little plus sign over here. So because I have either an addition or subtraction sign, I have to take a few more steps to make sure that I dot my I's and cross my T's. So here we go. First, I need a common denominator between R1 and R2, which is, of course, multiplying them together. Like, generally, if you can't find a least common denominator very easily, usually the easiest one to find is multiply the two denominators together, and there you go. That's your answer. So the least common denominator in this case would be R1 times R2. So what I did was I took each of the fractions and I just multiplied them by 1, which is one of our favorite math tricks. So in this case, I multiplied it by R2 over R2, and I multiplied this fraction by R1 over R1, keeping the 1 over R1 and 1 over R2 still there in our, so that it's a little bit easier to see as you track from this step to this step. So what do we do now? R1 and R2, we can now combine our fractions. We can add them together. So we've got R1 plus R2 in the numerator and R1 times R2 in the denominator, which is great. We have one fraction now. Unfortunately, that also means that well, maybe not unfortunately, but fortunately, that also means now that we've reduced everything, we can now do what we were originally planning to do and invert that 1 over R total so that I can actually get to the actual equation that I want. So for 2 elements, R total is going to be R1 times R2 over R1 plus R2. So basically, if you take all of the elements and you multiply all the resistances together, you will get the numerator if they're all in parallel, and then if you add them up, you'll have the denominator. So of course that means there's going to be some fractions, and they're probably going to be pretty pretty crazy fractions there, but they will be fractions, and we can deal with those fractions, and they're better. It's better than decimals. So here we go. R total would be 76 times 45 divided by 76 plus 45, which is 3,420 over 121 ohms. Now, can this be reduced? No, this can't be reduced anymore. And is this a really crazy fraction? Yes, it's a completely crazy fraction. However, it does get the point across that this is the answer. Do you need to put it down into like fractional, I mean into decimal terms by rounding all that stuff? No, you don't have to at all. Just leave it as a fraction. This is good enough, especially in my class. So that concludes how to do these two problems on the, in this circuits example. In the next one I'm going to do is an example problem with a combination circuit. So good luck in your studies, and may the force be with you.